Welcome to lesson 4.2, function notation. The I can statement or the objectives are to define function, review function notation, review the vertical line test of a function, define the domain and range of a function. Please use the notes that I gave you in class today to follow along with the lesson. Definition. A function, the word that I would like you to fill out is the word function. A function is a relationship between two variables such that for every value of the independent variable, there is at most one value of the dependent variable. A function is also a set of ordered pair in which no two pairs have the same first coordinate. Let me give you an example of that. This is an example of a function. This is a growth chart of Rachel's height as she grows. You will notice that for every age, for example, at age 2, Rachel is approximately 33 inches tall. For age 12, she is approximately 64 inches tall. At any given point in her life, she is at most one height. So examples of functions, such as Rachel's height is considered a function. If you're given a set of ordered pair, for example, 5, 6, 7, 9, 8, 16, those 3 points would be considered a function. However, this is not a function right here. If you're given points such as 5, 6, 7, 9, and 5, 8. That is not a function because I have a pair that has the same first coordinate. It has the same x coordinate. That is not a function. Another way that you can tell whether or not a graph is a function is by using what we call a vertical line test. By definition, a vertical line test is if no vertical line crosses the graph more than once, then the relation is a function. Here's an example of a function. Imagine that I have a vertical line and I am going to run that vertical line across my graph. You will notice that no point on the graph does the vertical line touches the graph in more than one place. That is considered a function. Here's another example of a function. You will notice if I run this vertical line across, it will not touch the graph in more than one place. Right? What is then not considered a function? That is not a function. And the reason why this is not a function is because if I run my vertical line across my graph, at some point, for example, right here, you will notice that it crosses the graph in 1, 2, 3 places. It crosses the graph in more than one place. So that is not a function. Once you determine whether or not something is a function, function notation emphasizes the dependent relationship between the variables that are used in a function. The notation, the most commonly used notation that I've seen is f of x. And that indicates the value of the dependent variable y also known as the f of x, are explicitly defined in terms of the independent variable, which is x. The second most commonly used notation that I have seen is g of x. And in pre-calculus, I've also seen h of x being used to define functions. I would like you to stop the lesson and open your book to page 180 for the investigation. The investigation asks you to identify which one of these are functions and which one of these are not a function. Please take some time to do that, and we will come back and press play again, and I will tell you the answers. Here are the answers to the investigation. A is a function because if I run a vertical line across the graph, you will see that at any given point, it never crosses the graph in more than one place. B is not a function because you'll notice if I run a vertical line test across the graph, at some point it will cross the graph in more than one places. C is a function because at any given point it never crosses any of our scatter plot in more than one places. D is a function because all the first coordinates are different between x and y. E is also a function because the first coordinate is different. It's okay to have the second coordinate, the y coordinate, to be the same. If you graph this, what you will get is just a horizontal line at y equals to 2. F is not a function because you notice that x equals to 1, I have two values of y. I have x going to 1 and also going to 3. That has the same first coordinate, so therefore f is not a function. If we continue with the investigation, letter G says, if the independent variable is the age of the children in the classroom and the dependent variable is the height of each student, is this a function? I would argue that this is not a function. The reason is because at this point, being in either 9th or 10th grade, most of you are between 14 and 15 years old, and chances are I'm going to find two of my students that have the same height. So therefore, I would argue that that is not a function. H says the independent variable is an automobile in the state of Kentucky, and the dependent variable is the license plate. And to me, that is a function because every single automobile in the state of Kentucky will have a different license plate. So therefore, I would say that is a function. I says the independent variable is the day of the year and the dependent variable is the time of the sunset. You could argue either way. To me, this means that the sunset and the same time in the same day of the year. And the answer is no. We can approximate when it will set, but we cannot say that it is exactly the same. So let me recap what we just did. A would be a no. Oh, A would be a yes. B would be a no. C would be a yes. D would be a yes. E would be a yes. F would be a no. G would be a no. H would be a yes. Let me move that up. And then I would be a no. I hope that you got all of it right. Now let me show you how it's being used. I have two examples to do. All right.